Hello sir, myself MD SAKIL Mondal. I am from ECE third year. My roll number is 34900323024. Today my topic is pulse coded modulation. Now what is pulse coded modulation? Pulse coded modulation is a method of converting an analog signal into a digital signal by various processes. The number one step is sampling. Sampling means taking measurements of the signal at regular intervals. Then quantization. Quantization means rounding each sample to the nearest allowed value. After that, the final step is encoding. Encoding means representing each quantized value as a binary code. Now there is a diagram of how PCM works. At first we take an analog signal, then we sample it and we will get a PAM signal or a sampling signal. After that we quantize the PAM signal, then we will get a quantized signal. Now we encode the quantized signal and we will get some digital data as a form of digital signal. Now when we elaborate the steps in PCM, at first we have to elaborate the sampling. The analog signal is measured at fixed intervals in sampling, and these fixed intervals are called sampling period, which is also denoted as TS. Sampling rate must follow the Nyquist rate. It means sampling rate f is greater than equal to 2 into f max, where f max is the highest frequency in the signal. Now there is a diagram of how we sample a analog signal. We take measurements after a fixed time interval. Here the time interval is Ts. We take 6 values of the analog signal and we sampled it and we get a PAM signal or sampled signal. Now we get into the quantization part. Each sample amplitude is approximated to the nearest discrete level. Quantization introduces quantization noise or error, and in quantization more levels means less noise. Since the original signal can have an infinite number of signal levels, the quantizing process will produce errors called quantizing errors or quantizing noise. There is a diagram of the quantization process. The dotted signal is the input wave and the levels are quantized output, and in the below of this figure we can see the quantized error or the quantized noise. Now we know that in analog signal have continuous time and continuous amplitude. After we sample it, the signal have discrete time and continuous amplitude, and when we quantize the PAM signal, we get the digital signal which have discrete time and discrete amplitude. Quantization is a non-linear transformation which maps elements from a continuous set of finite set. Now we need to know a thing which is called SQNR, signal to quantization noise ratio. And why we need SQNR? Signal to quantization noise error tells us how strong the actual signal is compared to the unwanted noise from the quantization. It measures the quality of digitization. It helps decide bits per sample for the desired clarity we want. It balances quality versus bandwidth. And it compares performance of different PCM methods. And we can say that higher signal to quantization noise ratio means clearer and more accurate signal. Now SQNR, the signal to quantization noise ratio. of the quantizer is defined as S by N. It is a ratio. So the ratio will be between signal power, which is normalized, and noise power, which is also normalized. If type of signal at input, that is xt, is known, then it is possible to calculate the signal power. And we know that noise power is V noise square by R, where V noise square is the mean square value of the noise voltage and R is the load resistance. Since noise is defined by random variable epsilon and probability density function, which is also known as PDF, which is f of E of E, and the mean square value is equal to E epsilon square is equal to epsilon square. The mean square value of a random variable x is given as x square is equal to, and there is a integration part which we can see. At first we did the integration and we put the value of mean square value and f of epsilon, E epsilon, D epsilon, and with the error in the limiting part we put the plus delta by 2 and minus delta by 2 for the error calculation, and we get that the total noise will be, the noise power will be delta square by 12. And when the load resistance, we suppose we take the load resistance as 1 ohm, then the noise power will be V noise square by 1, load resistance will be 1, then the value will be same, which is delta square by 12. Then the number of bits V and the quantization levels Q are related as Q is equal to 2 to the power V, and when we put the value of Q in delta's equation, 2x max by Q and 2x max by 2 to the power V, and when we calculate the SNQR, S by N, we put the value P by the noise power. When we put the value of noise power delta square by 12 and we calculate it, then the final equation will be S by N is equal to 3P by x square max and whole into 2 to the power 2V. And this equation shows that SQNR of quantizer increases exponentially with increases bits per sample because it is proportional. Now we came into the part of encoding. Each quantized value is assigned as a unique binary code, that is 0 is equal to 0000, 1 is equal to 001, 2 is equal to 010, and etc. Number of bits per sample V is equal to logarithm on the base of 2L, where L is the number of quantization levels. When we'll discuss about the transmission bandwidth, it's bits per second or bit rate, we can say that R is equal to V into Fs, where Fs is the sampling rate and V is the bits per sample, and the minimum bandwidth will be R by 2. Now when we take an example of PCM of speech, our speech, the speech bandwidth we know as, the value of speech bandwidth is 300 to 3400 Hertz, and the sampling rate Fs is equal to 8 kilohertz, and the quantization level is 256, or V we can say that 8 bit per sample. When we'll try to calculate the bit rate of our PCM, a bit rate of our speech, then we get V into Fs is equal to 8 into the sampling rate is 8 kilohertz, so 8000, and we will get 64 kilobyte per second, and the minimum transmission bandwidth is R by 2, bit rate by 2, so it will be 32 kilohertz. Now when we will discuss about the advantages and disadvantages of our PCM, the advantages are high noise immunity, and it can be stored and processed and regenerated easily. and it is secure and flexible for multiplexing. And the disadvantages we will can say requires longer bandwidth than analog system. That's why we use the LPF. Then complex circuitry for quantization and encoding. And at last or at the end, there is a full diagram of how the PCM generates or the PCM pulse coded modulation works. At first we take the analog message signal, then we pass it through LPF, then we sample it, then quantize it, then encode it, and the PCM output given to the channel. The encoded value will be given to the channel, and there is a regenerative repeater, and we get into a channel output. There the circuit regenerates and decodes again, and then we also filter it with the reconstruction filter, and we get our desired signal by pulse coded modulation, and it reaches at the receiver section as of the destination. That's all for today. Thank you, sir.